Oke ya, dan
Tes. Test.
Okay. Are you familiar with?
Hello, hello, testing.
Clip it to your.
Testing, testing.
Ready?
Hello, hello, hello. Can you hear me? Hello, hello. Can you hear me? Can you hear me? Hello, hello. Hi. Okay. All right. Okay, cool. Okay.
Good evening, everyone. Welcome back to Friday Hacks. So today we are very excited to invite Xue Yao to present stuff about Coreboot custom laptops. Okay, so over to you.
First, I must apologize for wearing a mask because I'm feeling like really bad these few days. So, anyways, I'm Xue Yao, and I'll be doing a presentation on Coreboot and custom laptops. Okay, so this is like the overview of what I'm gonna do. You can ignore most of it because this is like for posterity if you ever like want to view it back. But anyways, all right. So a little bit about me. I'm really just a hobbyist. I'm not a dev. I'm not from CS. So this is actually my first time in NUS Hackers as well. It's my first time attending, ironically as a presenter, but yeah, so this is what I do. I build custom laptops. You'll hear about it at the end because I was told to like present more about the technical stuff. So there's no notification. Okay. So I was told to present more on the technical stuff. So I won't like talk much about what I'm doing as like building custom laptops. But yeah, so I'm graduating December. I took a gap semester to work on stuff. So soon to be unemployed. Yeah, like I assume half of you here. All right, so first we'll talk about this guy. Do you guys know about him? No, he's the guy who built GNU. So he's like the other side of the coin of Linux. You know, when you write Linux, it's. Oh yeah. He got. I think he didn't get kicked. He was suspended from MIT because he made some like weird. Oh, is it? Okay, yeah, I think he was suspended for everything. So, so this guy's a little weird, but we don't care about what he's doing now. We care about what his philosophy is. So he founded FSF, which is Free Software Foundation, and he's the guy who wrote GNU. So when you install Linux, right, it's actually GNU/Linux, or like what he puts it, GNU plus Linux. Yeah. Okay. So. So they have a kernel as well, but it's pretty trashy. That kernel is really, yeah. I mean, he tried to build a kernel, but it kind of failed. So everybody's just doing both at the same time. So yeah, so this guy he also wrote GPL. I assume most of you have heard of GPL, right? If you haven't, maybe. I mean, no, GPL license. Yeah. So when you need a git and you need to, yeah. So you need to define it. So he's the guy who wrote the first 2 or 3 versions. I can't remember, but yeah. So he's the guy who founded all these things, and his philosophy is that he wants things to be free as in freedom, not free as in no money, because you can actually charge money for free software, believe it or not, you can. So he's the reason why a lot of our things are like great, like Linux, right? So Linux is great. So Linux uses GPL as the version, as the license. So the main thing I'm talking about is that his philosophy is that we want things to be free as in freedom.
Free as in no strings attached.
Yes, no strings attached. So means no warranty as well. So if you blow up your laptop, I have done that before. So yeah, just be careful. All right, okay, so to the more technical stuff. Just as an introduction, what's a firmware? Because Coreboot is a firmware, right? So firmware is like it's written there. It's the first thing that you see. So when you turn on your laptop or a computer and you see a boot logo, Yeah, that's your firmware. So if you guys don't know what it is, that's the thing. And it's an independent piece of software. So if you ever like remove your hard drive and whatever else, don't remove your RAM, but if you remove your hard drive, you'll still be able to see a boot logo. It just tell you no hard drive. So if you ever wondered like where that is, right, or what that is the firmware. And that's the thing we're going to talk about. What else? Yeah, so it's the first piece of the code, that the CPU executes. So it's hard coded to execute from like this address. So that's the crux of a firmware of a computer. And for computers, right, the firmware is actually located on the SPI chip. So I will tear down my ThinkPad later, if time permits. And it's a tiny chip that you can write and read from. Yeah. So it's very small. It's 1 meg to 16 megs. I mean, okay, 16 megs you think is small, right? Because you know you can like one image can be like 10 megs if you have a DSLR. But I will show you later what you can achieve on like 4 megs, which is pretty damn cool. So yeah, okay, next. So before we go more onto it, I just want to talk about this thing because I think it's slightly relevant, or maybe less relevant than everything else. But BIOS and UEFI, right? It's actually two different things. So if you ever like install stuff and ask you, oh, you want to install, sorry, if you install an OS and you want to install, and they'll ask you whether you want like BIOS or UEFI. Yeah, that's what it's talking about. And it's a misnomer because BIOS is actually the what we call the older version, like the old stuff. So yeah, so you can read it. Am I blocking the screen? Should I sit down? Should I sit down? All right. Okay. Okay. So the BIOS, right? It's actually from like a long time ago. From the 8086, and it's from like 40, 50 years ago. So it's very, very old, but it's very simple. It's very, very short. So, and we had like decades of engineering expertise put into it. So I guess, well, I mean, it is what it is. And the pros is that it's very small and it has a lot of experience. I mean, a lot of expertise on it. But that's its cons as well. So it's very, very old, and it's got like legacy code all over it. So imagine like when you had like 512K of RAM, you know, so that's from that era or even before that. So that's BIOS. And now we have the shiny new UEFI, which is what we are, or not what we are, but it's what we install as modern OS now. I mean, it's not that modern. It was released like less than a decade ago. And most OS still supports MBR, which is BIOS. So UEFI, it's shinier, it's nicer, it's newer, but it's got a lot of problems. So its pros and cons are the same as well, because it's so new. It's got a lot of like holes. It's like Swiss cheese. So so you'll see later that that there's a group of people who actually likes BIOS standard as a standard. Anyways, I'm talking too much because this is not like super relevant. But anyways, so why Coreboot? Because why not, right? Some Google engineer was like, you know what? Let's build our own open source firmware. Because why the hell not? Because that's what Google does. So, but it's Google, and you know they're evil now. So ew, no. Okay, and you can learn stuff, but that's you know what? That's up to you, right? So, and that's not cool. So, it's open source. If you haven't guessed by now, it's fully open. You can fork the thing yourself. FORK, fork the thing yourself, and you can do whatever you want with it. Yeah, you can. So you know. Yeah. So there's like a lot of derivatives, but we're gonna talk about the main family, which is Coreboot. It's maintained mostly by Google, but there's a lot of like freelancers working on it as well, and like random PRs. I've submitted PRs before, and it's pretty interesting, I guess. And the most important thing about this is that it removes useless vendor codes. So if you ever launch like not ThinkPads, but like a more generic brand or smaller brand, you'll see that it says like a AMI BIOS or I think Megatrend. So those BIOS, right, is licensed from these companies. So these companies build BIOSes, and you license it from them and use their SDK to build your own BIOS. But like, what's the point, right? There's no point in getting them because you're working with like Intel stuff or AMD if you're an AMD guy. So we remove that. We basically cut them off and we just use like Intel's blobs directly. So you can use their Intel's whatever you want. And the most important thing about it is that as a vendor or as a manufacturer, you won't be able to maintain a BIOS for the next 5 to 6 years. ThinkPads are exceptions, MacBooks are exceptions, but your general your gaming laptops, they won't have like BIOS updates for more than 2 years. And you'll get like Spectre and some other like a lot of random stuff that could happen, or like exploits and problems that can happen. So that's a more important thing, right? You can maintain your own BIOS, and the thing is, right, all the laptops, or rather the laptops that I enjoy, are more than 10 years old, and I can update it by myself. I can patch whatever I want, and I can build on it however I want, because BIOS is ultimately the hardware abstraction layer. So just as an example, laptops before 2014 generally do not have NVMe ports. If you don't know, NVMe is a new standard of SSDs. NVMe uses PCIe lanes, which is the connection that which is the connection type. And PCIe's, but the thing is, PCIe's have existed long before, since like 2006 or something. So what you could do with these BIOS is that you could install them on a 2010 laptop and put a NVMe drive off it, and get like, well, it's marginally faster than SATA, but you could do that. So it's one of the few things that you can do, along with like a lot of other cool things that you can do, but let's not talk about it for now. And yeah, so, and also you look like a hacker man, and you get to show off to your nerdy friends, but then again, my nerdy friends don't understand what I'm saying, so I guess I'm presenting here, right? Okay, so all right, next thing. This one is the part that I actually care more about, which is the privacy concerns behind Intel chips. So it, yeah. So every single CPUs, yeah, they have. So I'm going to talk about that. Intel, they install a thing called Intel Management Engine on every laptop since 2010, or rather every computer since 2009/2010. And that is a coprocessor inside your computer that runs 24/7, even with, okay, so it doesn't run with power, it doesn't run without power, obviously, but as long as you plug it in, even your main OS is off, it will turn on. It has its own RAM, it has its own everything, it runs on the background. It has direct access to your gigabit Ethernet, and new laptops, right, they have Wi-Fi soldered on. It has direct access to Wi-Fi as well. In short, it's NSA's backdoor to everything that, yeah, I'm not even kidding, man. So the thing is, right, there was somebody actually saw a leak, well, not leak, but like a glitched version of Dell's website where they enabled US military to buy laptops with the ME turned off. So the US military knows that it's a backdoor.
So, because you were saying NSA backdoor, right? But I think the bigger concern is not just this NSA backdoor. You talk about the new exploits, right? Like what?
Yeah. So like I said, right? So if there's ever an exploit to management engine, well, your laptop is basically screwed, and it has like ring like -3 or something, like basically ridiculously low level. Yes, direct access to your RAM. So even if you encrypt your shit, right, you will get decrypted because it's on the RAM. So don't think you can exit and like leave from it. So I guess that's what like Apple is trying to do, because they switched to ARM. They were like, nah, I'm not gonna use Intel and like their junk. So they started using that.
I thought the concern is more like the time they had the Focal, the laptops and whatever slowing down because so that's the idea. Cannot Intel like.
Yeah, I mean that as well, of course. So I mean that was a joke, right? So Apple was doing their own thing, and
they don't use TPM.
it's not this is not on the TPM. This is on the chipset. This is on the PCH. So like on the picture, right? It's literally here. This is your CPU. If it
Subsystem in the CPU.
yeah. So this is a CPU chip. So if you ever tear down a laptop and you look at it, you'll look something like this with 2 chips on it. And you're gonna like, what is this? Well, this is the PCH. But then again, it contains everything else that spies on you, and you cannot remove it because it's embedded in PCH. PCH is like, it's like the glue to your CPU. It holds your communications and everything else. So you need your USB. Yeah, it comes from PCH. You need your, I think, PCIe comes from PCH as well. So everything is on the PCH, and ME has direct access. So this thing is like a terror. So I mean, of course, we're all like normal people, so we probably don't care about it. But I'm just telling you that this thing exists. So okay, and it controls everything. Like I said, it has direct access to RAM. That's like ridiculously dangerous. It has direct access to a gigabit Ethernet. So even if home's home, you can't tell. You can't really tell. I mean, you could probably tell, but if your home's home to like Intel, right? You don't know what it's doing. It could be just Windows doing updates. Sorry? I mean, most of the time you're using Intel's. Yeah, then it probably doesn't have access lah. But I'm talking about most laptops, because well, everyone here uses a laptop. If somebody here don't use a laptop, please tell me, because. Yeah. And the thing is, right? Okay, so ME, right? What it could do, what Intel says it does, right, is that it helps you init your like RAM and stuff. But the thing is, right, we found out it doesn't really do. Okay, it does do that, but we don't need it to do that. And there's people who actually remove the entire ME, like the block, the firmware, and it turns out that the system can run, it can boot. After half an hour, the thing will shut down. So Intel has set a hard switch to just shut down if it doesn't detect any management engine, or like you remove the software. No, you run for half an hour and then shut down. Yeah. Yeah. So yeah, if you look it up, right, more than half of Wikipedia is on like exploits. It's absolutely ridiculous, and nobody cares because, well, like I don't know why, but nobody cares. So, and no, AMD doesn't help you either, because AMD has its own thing. It's called AMD PSP. We're not going to talk about it because I have no idea what it is. But yeah, it's kind of the same thing. Okay, so before that, right, you need to know what it's meant for. This is designed for enterprises to remotely manage their machines. So let's say your laptop has some issues, you bring it home, or like you're traveling, like on a business trip, suddenly it shuts down. You're like, how do I fix this? Then you go to a hotel, you plug into a LAN, somebody like on the other side of the earth can like manage your laptop. That's what it was designed for. But no home users need this. Like, we don't need this. I don't need this. Like, do you even know what it is? You don't, because you don't need it.
Isn't it also a system? Because I thought, isn't it the system where you sort of like have updates for the CPU?
No. It doesn't go through its own channel. You have to like allow it to update. But anyways, okay. So next part. Okay. So this is the more technical stuff. For the BIOS, right? Because it's a whole block, or rather, it's like a 8 meg or 4 meg firmware. So Intel has defined what it looks like, and it looks like this. You can take a look at it yourself. This is very, very boring, but I thought I need to put it here because you need to know that there's a structure to it. Okay, so there's a structure to it. So it will go to the it's called Intel FIT. You can look it up next time yourself, but it defines how the actual chip is laid out. So it doesn't care like what BIOS you're running, whatever. It defines how the chip is laid out. So we'll talk about you'll see later. So when you dump the entire firmware out and you run it through a tool that actually can tell you the information, you'll see that it actually tells you these things. So so the first part is the flash descriptor, second part is BIOS, third part is the management engine, and the fourth part is the gigabit Ethernet. So these are the components in a typical BIOS, like BIOS as in the entire firmware itself. This is what it comprises of. And so as you can see, the management engine firmware is inside there. It's actually here for easy updates now, but who knows, right? Maybe like 5 years later, they decide to integrate it directly inside the PCH. So for now, we can actually like play around with it, but in the future, we can't anymore. So for now, we can. So interestingly enough, there's also gigabit Ethernet, which is the Intel's NIC. It's also a firmware. It's also a part of the firmware. Yeah, and some other stuff, but these are the highlights. Of course, the most important part is the BIOS. So like I said, right, it's a misnomer that BIOS refers to the entire thing, but actually it's entirely called firmware, and the BIOS refers to a part of it. So, sorry? It's some other like stuff, it's like some init stuff, like some other, like, yeah, you can look it up. You can look it up, Intel FIT. There's like a 100-page document on it if you're ever curious. Yeah, you could. So, part of the BIOS, right, is Coreboot itself. So Coreboot actually exists on the BIOS portion, not on the entire firmware. So like I said, it's a misnomer. So that's why I actually spent one slide talking about this misnomer, because if not, you guys will be very confused on what the hell is going on. So Coreboot is actually a part of the BIOS, and Coreboot itself has its own defined layout, its own defined system, and its own definition of everything. So what is cool about Coreboot is that you can install your own payloads. So you know, normally when you turn on a computer, you can choose your, I mean, if you ever do, you can choose your boot device. You can, like, if you have a desktop computer, you can change your clock and whatever. Yeah, so that's one like application on the on the UEFI firmware. So what Coreboot does is allows you to augment this entire thing. So it allows you to deploy your own payload, which includes this. You can ignore the first two because you probably won't know what it is. You can deploy your own grub. Yeah, you can. So you can deploy grub2 on it. That means that you can boot directly to grub. I don't know if you understand what this means. It means that you skip like the boot logo. You just see grub directly, which is pretty damn cool. And from there, you can actually chain load another, like your own hard drive's grub. So that means that you like skip, well, most of the things in the middle. So later I can show you what's going on. And the coolest thing is that you can run Linux on it. That means that you can, yeah. I mean, obviously, right, because we are here and use hackers. So you can run Linux on a 16 meg chip, or on this laptop, it's 12 megs, or later you'll see it's actually 4 megs. And I've not one, but like a couple of Linux. No, it's Linux inside a small chip on your computer. There's no hard drive on it. I can show you, I can dismantle it and remove the hard drives, and you'll see that I can still boot Linux on it. Of course, it's rudimentary, and you probably see only a shell, but it's pretty damn cool, you know? So this is what you can do, and you can define whatever you want on it. And okay, so some demo stuff, just to give you guys more perspective, right? Okay, so I need to switch this. Yeah, okay, so just now what was, okay, I think you guys, some of you know what's TNO core. It's a UEFI firmware that is available on QEMU. If you guys have ever tried QEMU, you'll see it booting right? Because it looks like a machine. So I'm going to do that on a real machine. And then you will like think, wow, that's cool. But actually, yeah, so okay, let me figure out how to use this. Okay. Okay, perfect. Okay, so this is a schematics of this laptop that I have over there. It's called a T440p from it's a ThinkPad. It's from a long time ago. It's from 2014. Not really long time, but it's relatively long ago compared to your new modern netbooks and stuff. And this is a schematic of it. So just disclaimer, Lenovo, don't sue me because this thing is, well, I found it on the line. But anyways, yeah, okay. So these things are not supposed to be online lah, but you know what? It's China, you know, so it's made in China. So yeah, okay. So you can see the entire like schematic here, but I would like to point to where is it? Okay, so you can see the RAM here, and you can see like miscellaneous and other stuff. Let me find, where is it? SPI. Oh. Yeah, there's 99 pages because, well, it's difficult to build a laptop. And also this is considered very nice because they label everything. If you go and look up some random laptop, right, you'll find like some of them don't even have proper schematic, like no labeling, nothing. Let me see if I can find it. Ah, there we go. 12, page 12. Yeah. Page. Is this it? Nope. PCH. Yeah, okay, so the chips are actually connected here. Let me see if I can actually find the chips. Let's see. Ah, there we go. Okay. So wait, is it this one? Yeah, okay, great. So this is the actual chip that contains your firmware. It's literally a chip. And you can see it has 8 legs. And if you know what it is, it's SPI. So I will tear it down later and just show you guys. But just to give you a perspective, right? Because if you think it's like very far away, no, it's just a chip on your laptop, on your computer. And it's a chip on every single computer out there. It's an SPI chip. Yeah. You'll see it. It's not. This is separate, and I'll show you guys later. I'll FaceTime myself and like, yeah, you'll see here. Okay, so sorry, back to the presentation. It's illegal. Google it yourself, but it's very simple to find. You'll probably find it. Okay, so okay, I'll tear it out. FaceTime myself first. Okay, my yeah.
Can you try to go to preview? QuickTime. I think QuickTime you can open up a video of your phone.
You can?
If it's logged in the same Apple ID.
Yeah. How?
Going to file, new recording from member. And then instead of this, there is, oh damn it, I can't see it. Okay, then I think I have to try calling.
Okay, yeah, okay. So I'll call myself. No, my laptop is not. My laptop is not.
Oh, yeah, I can just join the Zoom.
Let's see.
I can do it. Yeah, give me 1 second.
Let's go browser hacker.cc.
I can do it from my phone, then I'll just.
HCKR/FH Zoom. Oh, perfect. Okay.
Recording in progress.
Oh, okay. Okay, so I need to join in on my phone as well. HKR.cc/FH Zoom. Hang on. I'm trying to log in right now. Oh, perfect. Okay. So I cannot start the video. Just enable video for all. There's only 12 people. Yeah. Okay. How do I put this on the Oh, okay. So, do you mind?
Yeah, I can hold.
So let me grab the screwdriver.
Yeah, full. I think maybe.
Okay. Okay. Okay.
Oh yeah, sure. There you go.
Okay. Okay. Do you mind? Okay.
Wait, just hold this.
Yeah. Just come directly here.
Oh, actually, no. I wanted to check out. Okay.
Okay. So yeah, apologies for the very weird setup. I didn't ask about the visualizer. Okay, so this is yeah, okay, so this ThinkPad, right? This chip is right here. It's actually very exposed right here. Yeah, I don't know. Okay, yeah, it's right here. Yeah, it's right here. So it's literally an SPI chip, and I'm not gonna show it right now because this thing will take forever. But you can literally use. Do you mind? You can use this and this. Let me just grab it.
SPI Pro. Oh,
Yeah. So you can use this to clip it on the BIOS chip, and you can dump the entire firmware, right? Yeah, directly. So this is how you literally dump firmware from laptops and in general like devices. Yeah. So sorry.
You need to buy those to go and change the thing.
Yeah. So of course, so this is what it looks like, and yeah. So this is a laptop, and well, it's not a very like massive teardown, but this is what it is, and
She's not thinking of like buying
oh yeah, but you can actually install Coreboot yourself. So on this laptop, I have Coreboot on it with TNO Core. So hopefully you can see it in action. Do you mind?
Yeah.
Okay. And there's no power. Okay, perfect. Okay, this laptop hasn't died on me.
E440 only.
Yeah. Have you guys seen this? So this is if you ever use QEmail, you will see this. And I'm literally running, well, QEmail, right? But it's actually TNO Core. So this is a UEFI firmware, and I'm gonna boot from it. I'm gonna boot Debian on it because I'm gonna show it. The thumb drive is not for anything. My bootloader is screwed, so it's kind of not working well right now. So I'm just gonna use this to help me boot from my hard drive from my disk. The hard drive is here, by the way. Yeah, so if you guys haven't torn down a laptop before. Yeah, okay, so this is a very old laptop. It doesn't have M2. I mean, it could. Yeah, 24. It could have an M2, but yeah. All right, okay, so I'm gonna give you a very weird booting because my bootloader is kind of screwed right now. So I'm using a thumb drive to help me boot. Okay.
Folds the rest of the bootloader.
No, yeah, it's a portable bootloader.
Okay.
Yeah, so it's great
Just
if
like
you
grub
ever.
on it?
Yeah, it's just grub, but it's like a pimped out grub. It's like 300 megs. I don't know why it's 300 megs, but it's a 300 meg grub. Yeah, if you guys ever want to like screw around with these things, right? It's very cool, but it's also very big. I don't know why. It's yeah. Yeah, well. All right. Okay. Okay. So apologies for the super long boot, but.
Booting off a thumb drive.
All right. Okay. So let's boot directly. Okay. Yeah. So if you guys realize, there's nothing different about this laptop compared to a normal ThinkPad, except that it's running open source firmware. So everything from the ground up, except Intel stuff, is open source. Because I'm running Debian, right? So everything is technically open source, which is pretty nice.
The newer laptops don't allow you to.
Yeah. You can't screw around. Okay, so I'm gonna.
Some shops you buy disable only for.
Oh yeah. Okay. Okay, so I have another copy of. So you guys saw just now that I was running TNO Core, right? So I'm gonna flash another BIOS right now with another payload on it. Yeah, so I'm gonna do it right now, and you guys can see it's pretty cool. So I'm gonna run this command, and it's gonna like flash the BIOS directly in. Yeah, so it's flashing in BIOS right now. So if you guys have ever like flashed BIOSes before on a desktop, it may look like this. It may ask you to like install flash ROM and type in some random commands. Well, now you know it's just writing to an SPI chip on your machine. And flash ROM can write to any device that is like you can write to any chip basically. So if it supports the SPI reader thing as well, you're gonna use the same software.
Yeah. Normal BIOSes unlocked to be.
No. So I'll talk about that in a little bit lah. Okay, so it's verified, it's done. So I'm gonna shut it down right now, and you'll see that it comes out to some other stuff that you'll think it's wow, it's cool. But yeah, okay. Rambling a little bit.
Tetris.
Well,
Man to Tetris, Tetris in the BIOS.
okay, so let's run. Okay, so this is CBIOS. It's BIOS, so it's not UEFI. So this thing that cannot boot my Debian, cannot boot anything basically. It's very old, but it's very secure supposedly. It's more secure than UEFI. So if you guys actually want to like play around with this, CBIOS is pretty cool. So I'm gonna run number 7.
Oh my god.
Okay, and okay, you guys don't know what it means, right? It means that I'm running this directly off the BIOS chip. I will pull out my hard drive right now and show you guys. Okay, so always unplug your power, because if you don't do that, you're gonna burn something. So there's no other hidden drives on this. Well, I have no reason to lie to you, right?
How do we know you don't have the option ROM on the PCIe device?
Sorry?
How do we know you don't have the option ROM on the PCIe device?
I mean, that is kind of like an option ROM, but I don't have any PCIe device on this. This is a laptop. So I'm gonna remove the hard drive. Yeah, it's a 2.5 inch. So there's no other drives on it lah. Yeah. Okay. And I'm gonna just plug it in right now. Okay. And we're gonna play with something else called this thing. Okay.
What?
Yeah, okay, so this is a full Linux with GUI running on a BIOS chip. The BIOS chip is 4 megs, but I've got like 8 other stuff in there. So this is a full GUI, and you can, well, you have shell. So like I said, right, there's nothing here. There's no hard drive. There's no other hidden things in there. You can examine it later yourself. I don't mind. This thing is, well, quite old, so I don't really care if you break it. But of course, don't break it. But yeah, so this is running off a very tiny chip, and it loaded the entire OS onto the RAM. So that loaded in like 2 seconds. So yeah, you can technically have a full Linux on it, and you can have network. You can have networking. So you can, but I'm not gonna figure out how to work it, but you could, and you have like other stuff like Flappy Bird. That's okay. I died. Yeah, so this thing is running off a BIOS chip. Yeah. Okay, so that's all for the live presentation. You can play around with it later if you want. Yeah.
Are there some quoted to mod the BIOS? I put a bigger BIOS chip on it.
Yeah, you can actually do that. You could. So you can buy like a 128 meg chip, and you can technically load a proper Linux, more proper. You can compile the kernel yourself, and you can remove all the junk, but you could have a more proper Linux running on a BIOS chip with no hard drives. I don't know what's the purpose for it, but you could, because NUS hackers, right? I mean, I already did this, which is kind of pointless, but yeah, you could. So
You crap up your like main Unix, right? Then you just put into this and just prepare.
yeah, you could, but it's easier to just bring a thumb drive, right? So it's just something to show you that Coreboot could do anything. And so these things are exported as floppy disk images, and you can export. You can like install any floppy disk images inside there, and you can run it. Yeah. So like I just showed you, I have like Flappy Bird and a full Linux. There's a couple of homebrew OS on it as well. Due to type, I don't think it can run Doom, but well, welcome to try. Yeah, but it's big enough, I think, right? Yeah, you can compress it and it probably runs on it. So you could.
Do on the biohazard.
Yeah. So this is a very rough rundown on it. Okay. So back to the presentation. Oh, sorry. Okay. All right. Okay. So the next thing. Sorry. Yeah. Okay. You know what? Go ahead. Okay.
What happens if you like you choose another payload, like suppose graph, right?
Yeah.
Will the KVM be able to like boot my VM?
Sorry.
It's affected, right?
What? Oh, you want to use it to boot like VMs?
It's not
VMs.
affected, right? It doesn't affect my
I mean, grub takes in the config file, so you can drive or whatever, and you'll boot option. So what most people do if they actually run the setup, right, is that they will load grub as a payload and then load it a very simple config for it to chain load another config that exists on your actual hard drive. So you could technically pull that off, and it boots very fast, but there is no practical purpose behind it, other than like just being cool and showing off. Like
it's different, right?
Yeah, it's different. Okay, so sorry, yeah.
It doesn't affect the thing. Like for kernel development, you usually debug it using QEMU, right? But then for this one, what's the debugging process like? If you question this one.
You'll just not boot if it crashes, but if it doesn't boot, right, you can ask it to write a log into your SPI chip.
Is there like what debugging tools are there?
So for conventional laptops, you can. Okay, so if you didn't catch his question, how do you debug this thing if it doesn't boot, right? Yeah, in short, you don't, because it just doesn't boot. So you just pray, right? You just pray. But no, that's the brute force way. So you don't do that. You can ask it to write a log into the SPI chip, and then you read from it. So I can tell you, right, for a fact that the most painful thing you ever do, right, is clipping on the damn chip for like 20 times and it doesn't work because that thing is so small. So a lot of like online people, what they do, right, is that they'll solder 8 wires onto it because it's so painful to clip on the damn thing on the small chip. So you could do that. And there's some like special debugging interfaces that if I'm not wrong, it goes to USB, but I've not explored that before. So in general, you just ask it to write the logs to SPI. Yeah. The SPI is super endurable, don't worry. It can write like more than your SSD, so it's fine. Anyways, ME cleaner, yes, okay. So, okay, you know what? I didn't demo this, and you know what? It's fine. Okay, so, okay, we'll skip this part because we don't have enough time, right? Yeah. Okay. It's fine. Okay. In short, right, Coreboot can clean out ME as well, the management engine. So for there's some guy online who's like super smart. He wrote a script that cleans out the entire management engine, or rather like 90% of it. And you can run it alongside with Coreboot. So I can show you right now when you compile it, what it, oh no. Okay, yeah. Yeah. So you can neuter it. So you can, when you compile it, it's super easy to compile. It's literally just a 16 meg. Right? It's smaller than that, right? So if you want to like play around with it, you can. So under chipsets, you can scroll down, blah, 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 and you can strip down the ME firmware. And by that, you can tear down the entire, or not tear down, but tear down most of it. So you can have a peace of mind when if you want to like run secret stuff on it. Yeah. So you could do that. And you can like do some other stuff, but in general, this menu doesn't provide a lot of options. But you can like, let me see what other cool stuff is there. Yeah, so you can, so the microcodes, you can get the latest microcode yourself. It literally just generates from Intel's repo. So that's what I mean. You abstract away, or rather you remove all the vendor stuff and you do everything yourself. And you interact directly with Intel. So you get the best of everything. So sorry, PCH. Yeah, okay, so the ME removal, right, you will do that. So you'll remove like 80% of it. Right, okay, so this is a very quick demo. Okay, where is it? Okay, so that was supposedly the cool shenanigans stuff. Yeah, okay, so just to talk a little bit about the management engine in Coreboot. For newer laptops, right, it's very difficult to pull it off, or almost impossible, because for security purposes, Intel's, or rather the vendor signs all their firmware and literally burn it on the chip. So you are unable to install your own custom firmware at all for future, unless you know the vendor. which in that case you have to be the vendor, which I'll talk about in a little while. So you could technically pull it off, but it's more difficult. So you have no peace of mind in the future. Well, except okay, so you by now you'll be wondering what's the point of Coreboot in terms of what Google wants it, right? So Coreboot runs on every Chromebook out there. So technically every Chromebook has an open source firmware and technically an open source OS, but it's Google, so you know, don't be evil, right? But yeah, you could do that. So that's the kind of the future where it's not a very where it's not very friendly to hackers anymore. You could technically pull it off with specialized laptops that well I built. So okay, that was a nice segue. So so I built custom laptops. The image on the left is the same laptop as the image as the laptop on the right, except that I removed I installed a custom panel on it, and I replaced the keyboard and some other stuff in it. So I mean, if you want to have like a very secure laptop that you can build yourself and also have better hardware, you could do that. And the aftermarket display, right? It doesn't hook on the default display bus. So what it does is it there's an adapter for it that you can actually bring out the display port connection, and then you can bring it into the new display. So in short, you are jerry rigging this thing, but it's a very nice jerry rig. So yeah, with 3D printed parts and all. And so I actually went to Shenzhen not Shenzhen, but I went to China and went to Shenzhen, and like if you guys don't know, it's the largest electronics market in the world. It's really cool. I went there, you know, I talked to like vendors and suppliers and stuff. And it's a very, very interesting journey, I guess. If you guys never been there, you should once China opens up to tourists. It's very, very cool. It's 24/7, and like you can buy anything you want. Yeah, it's 24/7. You can buy anything you want. You can literally buy whatever you want. You want a RAM, you can go there right now and buy one. If you want like this CMOS or whatever, right? If you want a CPU, you can buy it. You can literally buy CPUs, laptop CPUs that are desoldered, they are ready for you in bulk. Like if you want like 1,000 chips right now, within an hour, you go there and tell them I want 1,000 chips right now in an hour, and they'll tell you the price. They won't tell you they can't do it, they'll just tell you the price. Yeah, and the price is usually like dirt cheap because it's China, right? So sorry. So what I've been doing recently is I've been upgrading older laptops. So so this was a laptop from 2010, and I work with vendors and I work with different people to produce a 2020 motherboard. So it's an entirely different motherboard. In short, I'm just using the chassis, and the motherboard is completely different. So it has a 3K display, jerry rigged as well, and there's a 3D printed port by it. So you will get a USB-C as well. So it's a 2010 laptop brought into 2020. It's a pretty cool sleeper PC, I guess, if you guys aren't into ThinkPads. But yes, this is what I could do. And you can put in like 64 gigs of RAM on this, and this is from like 2010. So if you ever like, I used to run 64 gigs of RAM, but that was way overkill, man. Nobody needs 64 gigs. Yeah, I don't understand why the 16 gig RAM on phones, but yes. Okay, and that's I think that was the slide. Okay, never mind. Yeah. Oh, okay. Yeah. Okay. So sorry. Yeah. Okay. I guess that slide was screwed up. This is my workshop in China. I work with my uncle to produce laptops. He builds. I tell him how to like go about it, because I'm not in China, as you can see, if you can't tell. So he built. He does the hands-on, and I do all the software and all the like tutorial and stuff, and I get him to do all the things. And if I need to like get stuff like get parts and whatever, I'll do it, or I'll ask my uncle to do it, and they will just ship directly to our workshop in China. Yeah, so you can technically run a small modding business with literally no screwdrivers on you. I mean, I do, but that's because I brought it, right? So usually I don't bring a screwdriver around with me. So you could do this. And so I've been doing this for a couple of years. I have a website if you guys are interested. So this is my info. Yeah, thanks guys. I mean, you could do that, and we can like.
Is there any chance that course, I might actually
No,
buy one.
no, but if you can invest 100,000, then we'll get it done. We'll get it done, man. Of course, yeah. Sorry. Yeah. Any questions? Anything? Okay, great. You can like talk with me later lah when we have dinner.
Yeah, so for the interest of time, we are not going to have Q&A now. If you have any question, you can stay back and hang out with Xue Yao. So big thanks. Okay, so we are going to have a 15 minutes break, and there will be pizza and bubble tea. And please be back at 8:10, okay? So.
I'm not gonna set out my thing straight. I could do that, but yeah. Wait, so like when you
We are very excited to invite Ajinkya, and the topic of his talk is the hard things about hardware. So over to you.
So, hi everyone, my name is Ajinkya. Thanks so much for coming over on Friday evening, before the start of the weekend. So the last thing you go home with is probably my talk. So hopefully, yeah, you get something out of it. Basically, I was a PhD student at NUS for the last 4-ish years. And then I went through GRIP and we spun off a company. So basically just going to share a little bit about what it is to go from a hardware in lab setting to an actual company, and some ways about doing it, specifically with regards to like hard tech. So for hard tech, I'm going to cover basically anything which involves high capital expenditure. So it doesn't just have to be electronics and like consumer electronics. It can be something like biotech, for example. So there's certain challenges that come into play. So I'm just going to share that. So just a little overview about what we do. So our company is called Seamless. The whole idea behind it is to develop portable, wearable haptic solutions. This is what we pitched to in GRIP. We are actually undergoing like a pivot currently. So essentially what we have is these pneumatic actuators that inflate. You can feel impact in places around your body, similar to Ready Player One. I see some faces, it's a haptic vest.
Yeah, I've seen Flo like play VR chat that.
Right, I know, yeah. So essentially you're kind of doing the same thing, we're just doing it with pneumatics. And we like to think of ourselves as like we're the Lego of haptic interfaces. So we have a suite of technologies. This is just one of them. And we're combining them in order to create this modular platform where you can do a lot more things than just like full body haptics. But that's not the topic of today's talk for me. What we're going to see is the hard things about running a hardware company. So essentially, when it comes to hardware, there's a few challenges that come into play. And the first section, I'm going to mostly talk about that. It's why is hardware hard? Then in the second section, I'm going to talk about hardware cold start hacks, because essentially the most difficult thing with any hardware company is to get it off the ground. Once you get the momentum, things become easier, as with any company, but specifically with hardware companies, because your competitors now have the same challenges to come into play that you had when you started off. And then the third one, I'm going to like briefly touch over like some business models that some hardware companies use if we have time. But the first two parts are probably the most important. Probably the second part is the most important. So why is hardware like really, really hard? So if you are familiar with like Eric Ries's concept of the lean startup, it's quite simple. It's you have an idea or a hypothesis. What you do is you build something that allows you to either prove or disprove that hypothesis, right? That's your initial product. You ship the product, and what you do is you measure how it's doing. So it can be subjective metrics like customer feedback, or it can be objective metrics like data, like raw hard data. Like let's say it's a software app. Its data could be something like how often do people log into the app? How many people do they have in the network? Stuff like that, right? And essentially what you do is you learn from that, and then you fix whatever is broken, right? And the whole idea is you want to go through this loop as fast and as often as possible so that you get closer to product market fit, essentially. So it's like having a product which most people want to use. And in terms of software, funnily enough, pizza. So essentially, basically like lean software cycle, the way I look at it is you have a bunch of coders. Your fuel is pizza and coffee, and your output is code, right? So, I mean, we've been through that cycle for a pretty long time. I think pretty much everyone here is familiar with it. So with software, it's easier to ship this product, measure using data metrics, which you can take in from your software itself, learn. You go back, you discuss with your team what's wrong. If there is like a glaring issue, you apply a patch. If there is, if your product is like closer to like getting fit, it'll probably be more like a feature request or a feature improvement. And you can go through this loop pretty quickly because you can push the product out quite fast. Now, when you try doing this with hardware, the main issue that happens is you have this initial prototype, and then you still have to have like a software layer on top, because in today's era, you'll very rarely find hardware which doesn't have software because it has to talk to other systems. And then you build this, and here comes the problem. The moment you start building the hardware product, to get it into the hands of the users, these things come into play. Essentially, it's an issue with like having to push out the product to the supply chain, which is going to be your industrial designer. It could be your DFM service, which is designed for manufacturing. So something that helps you understand how to design your product so that it can be mass manufacturable, which you usually don't think of when you're building your prototype. And then you have an issue where you come into logistic problems because you have to physically ship the product to your customers. And this is super hard. So to get to this pilot stage can take maybe 3-6 months. Then you go through the same cycle again, data, customer feedback, learn, and then you prototype again. The issue is there's 3 places here, which is prototyping and as well as the supply chain and logistic parts, where you have extensive time and cost involved. That makes it super hard. So Tony Fadell in Bill basically says that on average, a product takes about 3 iterations and 9 to 18 months to actually be fully ready. That's a pretty long time. So the 2 biggest issues, like I mentioned, is iteration time and iteration cost. But I want to leave this section with like a bit of hope. So the things that make hardware really hard is actually what makes it easy once it gets going, because everybody else, like I said, is going to have the same issues. So it can be intimidating. So a lot of founders start off with something simple, like a mobile app. And counterintuitively, according to Jared Friedman, this is where it's actually easier to go with hardware sometimes, because once it turns out fine, and once the product is ready, you have a really good story because it's so hard to build. Yeah. So the 2 questions we're going to try and answer in this next section is, how do you solve this time and cost issue? So how do you iterate or validate faster and cheaper, which is going to be like trying to pull it closer to like the lean startup model for software. And how do you, if you can't do that, how do you raise funding so that you can actually build your product just with credibility, right? So you have to have somebody willing to give you money to build it if you can't build it fast and cheap, right? So we're going to talk about cold start hacks now. The first thing is, if money is your problem, do things that don't cost money. Super simple, right? Yeah. 3 really straightforward ways to do it is visual representation or demos. Then I'm going to talk about letter of intents, how to get them as well. And this weird thing here called board of advisors. How does that work? So for visual representation, it's quite simple. There's maybe 5 to 10 different ways to do it. This is mostly what I've found were relevant. You can have something like a concept video, website landing page, specifically for if it's a hardware product. If you're doing a Kickstarter campaign, what would be great is if you have CAD drawings, because it just somehow gives a little more credibility that you actually thought the design through. One of the things that hardware founders like to do is to create these plastic mockups. Mostly those are designed to be like true field products, and this is important for like consumer electronics kind of products, because people want to know how they would look like and feel like when they're actually at their home, in their home environment, or if they're wearing them. So these plastic mockups come into play there. And the last thing, which I think is the best, especially if you're going for something which is a very hard engineering problem to solve, it's computer simulations to show that it actually works. This specifically works if it's a biotech product, for example. So if you can show that a process works in computer simulations, at least you have some credibility. So I'm going to very quickly go into what we did. Yeah. Yeah, my brother actually made this. He's a media design artist. So one of the things that simulations can do is if you try and explain what you're building to someone, the most difficult thing for them is to understand what it looks and feels like, especially if it's something so different that they've never seen it before, right? And because all of us are tech people, if I try to explain it to you, you guys probably understand. But if you try and explain it to a 5-year-old or your grandma, right? They're going to be like, what's a haptic OS? Why would you need one? What is the thing, right? So when you show them and you're like, oh, okay, so you can feel these impacts that happen when you're fighting in VR. She's probably going to be like, yeah, whatever, but at least she knows what it's doing, right? So one of the things that this helps you do is it creates this credibility in a sense that you kind of know what you're building. And now you're trying to raise funding to actually execute on this dream. So you're kind of selling the dream, right? So this whole section is about how do you sell the dream so that you get money. What this also helps you do is the second part, which is get a letter of intent. So usually what a letter of intent is it's a non-binding contract, usually from the person you're directly targeting as your customer. And it sounds kind of weird that it's a contract but it's not really binding. But what it does is it shows your customers' intent in being able to purchase your product. And it's actually pretty hard to get. People don't sign LOIs left, right, and center. It's just super difficult to get. One of the reasons is because if the LOI falls through, it kind of affects their credibility a little bit. If you're dishing out LOIs. And what the LOI along with the demo can do is it can allow you to at least raise some funding from investors because it shows that there's some real demand for your product. So one of the mistakes that we made, and I wanted to make sure that I include this in this section, is there's a few things that you need to ensure when you're getting a letter of intent. You don't want to be super generic. You want to make sure that the LOI has requirements of what specific features that you need to build. If the customer is willing to express what problems they have currently and how you can solve them in the LOI, that's even better. And finally, if you can, I know it's non-binding, but if you can, get a price. If they can tell you how much they're willing to pay, it gives the investors a context to what the potential market size might be. Okay, so this is where the fun begins. Okay. Do you guys know who that is? Yeah, so this is Elizabeth Holmes and Theranos. So one of the things you can also do, and I specifically included this example, is because I wanted to express how this can go wrong, right? If you look at Theranos's board, it has a lot of big shots. What happens is when you have a board of people who are that powerful, essentially everybody just believes you. You can have nothing and they'll just believe you, right? And that's where strong advisory board comes into play. So if you have a mentor who's in the industry you're trying to go into, or if you can lock onto somewhere please, that'll help you raise money. One more. You guys know who this is, right? Yeah, WeWork guy, Adam Newman. Yeah, do you know his new company raised 350 million in funding? You guys know that? It's not a typo, it's millions. Okay. and from Andreessen Horowitz as well. It's an M, it's not a K. Yeah, and then I have a slide note which tries to describe what it's like doing, and I don't even know what it's doing. So if you want, I can read it out to you. So it's like, first, Flow is a technology first property management company handling day-to-day operations. Second, it's a real estate asset management company that owns buildings. Third, it's a financial services company. And fourth, okay, this is the best one. This mechanism that is going to take some value and share it with its value creators. Okay. If you guys understand what that means, please explain it to me as well, because I don't get it. And you can still raise 350 within funding. So yeah, so essentially what happens is, these are like basically like outlier examples, but if you have some form of credibility in terms of the people who are on your company, because Adam Newman has some sort of credibility as a founder previously, arguable, but that pretty much helped him raise this funding, right? So yeah, if nothing works, this is one way you can go. Just promise something, moonshot, and yeah, try your luck.
Isn't that called being a taboo?
Maybe.
Something like you related to your uncle is like some,
Oh, nepotism.
yeah, something like your uncle is a powerful guy, then you're like, give you the money.
Right. Yeah. So in this case, it doesn't even have to be someone related to you. If you can get in touch with like mentors who are powerful enough, you can still, like, they will open doors for you. Basically, it's not a way that I recommend to raise, specifically because if you promise something that you can't execute, you're gonna hurt your reputation as well, right? So. Exactly. Yeah.
I know the other Korean guy is on the run.
Exactly. Yeah. So even with FTX as well, a lot of, yeah. So with FTX as well, like if you see the funds that invested in, they basically followed like lead funds who they thought did that due diligence, and they just followed, right? So a lot of times, like investors kind of sometimes tend to behave like sheep. It's like you get one and then everybody starts flowing in.
It's not get one, it's that they think that you are established, even though you're not.
Yep.
Because you've got some big thing, everybody follows you.
Yep, exactly. Yep. So the better way to do it is something like this. So this is specifically catered towards biotech products, but there's an electronics example as well. So if you are trying to build something, you can first build a scaled down version of it. In this case, this is a biotech company, Solugen, which I think they're doing genetically engineered organisms, if I'm not wrong. So this is their 2016 scaled down model, which is basically a beaker, which is about this big. And then that's the full scale plant in 2022, which is definitely not as small as that. So this is one way to do it. So you're trying to prove the principle, and you're trying to get credibility this way. This is definitely better than board of advisors. Okay, you guys know this guy? Okay, anybody want to take a guess?
I will, right?
So this is, okay, that's mine. My pointer doesn't want to disable it. Okay. Guess the video doesn't want to play in frame, so I'm gonna. That's the audio for his video. The video is not playing, it's weird. So let me just go back. See if it plays out of frame. Yeah, so the hardware equivalent, well, electronics equivalent of a scaled down model is an under-featured model. So you're basically just demonstrating essential features. This was the first prototype where he's actually demonstrating, like, it's sending SMSs. So if you actually know, Pebble started off as a company just different. I think it was called Impulse, and they were trying to send messages via Arduino to these remote devices, but they were actually designed to be mounted on bikes because Eric wanted to be able to read his text messages while he was on his bike. Right? Super dangerous, but hey. Yeah. So he just goes hack some open source. If you'd laugh even more if I actually played the music, but anyway.
So at this stage, was it still intended to be on a bike, or was it towards a watch?
It's pivoting towards a watch now, I think, yeah. This is probably 2013, 2014 video.
Oh, watch doing, oh, okay.
Yeah, for showing off the board.
Recording in progress.